In this video, we are going to see about tree and code tree. And tree is nothing but the subgraph of the network. And that any network can represented using graphs. And this tree is the subgraph of the network. And there is no closed path. That is the main thing. In tree, there is no closed path, but it includes all the nodes available in the graph. So this is the definition of tree. So tree is a connected subgraph of the network which consists of all the nodes of the original graph but no closed paths. And we can see all this definition using one solved problem. So next, the number of graphs is equal to the number of nodes in the tree. So the number of graph is equal to the number of nodes in the graph. Number of nodes in the graph is equal to the number of nodes in the tree. So how many nodes available in graph, that is also present in tree. So for example, n is equal to 3 in graph. In tree also n is equal to 3. So the number of available nodes in graph, that is equal to number of nodes in the tree. But the branches in the tree is less than the number of branches in a graph. So in general, if a tree contains n nodes, then it has n minus 1 branches. So in general, if a tree contains n nodes, then it has n minus 1 branches. And we can see the definition of all this using one solved example. So consider this point, and these are the nodes. This graph contains 3 nodes, 1, 2, 3. And this A, B, C, D are branches. So this is a graph of one network, and this graph having 3 nodes and 4 branches. So the definition of tree, it must contain all the nodes available in graph. So it must contain 3 nodes. In all cases, it must contain the 3 nodes. But there is no closed path. So we can take this one tree. That is a subgraph of this graph, connected subgraph, that is known as tree. So now we can know these are the branches A and B. So now we have only 2 branches. So n representing the node. So here 3 nodes. So the available branches is equal to n minus 1. So n is equal to 3 here. So we have 2 branches. In all cases, we should having only 2 branches. So next case, and there are 5 possible subgraph. So next case also, it must contain all the 3 nodes. And this is one, this B and C. Similarly, 1, 2, 3, 1, 2, 3, and we can draw this B and D, and this is B and this is D. Similarly, this is B and D. And next one, 1, 2, 3, and we have this 1, 3 and 2. And next one, 1, 2, 3, 1, 2, 3, and we have this A and this D, A and D. And these are the possible connected subgraph of this graph. So the condition here is the available nodes in the graph, that is equal to the nodes of the tree. So here the node is 3. So all the subgraph having 3 nodes. But the available branch is equal to n minus 1. So all the subgraph must having only 2 branches. And there is no closed path.